Git is a free version control system tool, and it is a tool you can download and install on your machine, no matter if it's a Windows or Mac OS or a Linux machine. And with that Git tool, you can manage source code changes of an application you might be writing or of a website you might be working on. Any source code, no matter which programming language is used or which kind of application is being built, any source code can be managed with Git. Now, Git helps with managing your source code by, for example, allowing you to create snapshots, so-called commits of that source code at any point in time you want to create a snapshot. You can also work on multiple versions of the same package or app or website or whatever simultaneously with help of a feature called branches. And you can easily switch between different branches and snapshots by checking them out. And these are all terms you will frequently hear in conjunction with Git. So the idea behind Git is that you can use it to control your source code and, for example, easily roll back to older code snapshots if you messed something up, or develop new features simultaneously with your existing code without breaking that existing code, which might currently be powering your active website. And you will see these things and Git in action in that Crash Course section I just mentioned. So that's Git. What is GitHub then? GitHub is a company, and it is a company that offers cloud Git repositories and services related to that code which you're managing in the cloud. Now, a repository is simply a bucket, a space that contains your code. And when using Git, you have local code repositories. Any project that's managed with Git is called a repository. When using GitHub, you can also create such repositories in the cloud. And you can connect such a cloud repository that you created with GitHub to your local repository and then push changes to that cloud repository or download them from that repository. And the idea simply is that if you, for example, lose your local machine, if it crashes and can't be restored, you don't lose your code. Or if you're switching to a different device, you can download the code from this cloud repository and continue your work on it. Now with GitHub, you can create public and private repositories, and you can also manage who has access to these repositories, who can change the code, and so on. But it's not just about storing code. GitHub also offers features related to code management and collaborative development. It offers features called issues or projects or pull requests, which you will see in action in that Crash Course section I mentioned before, but which are in the end about tracking bugs, reporting bugs to code maintainers, organizing code projects, suggesting changes, and many other things. So GitHub is not just about storing code in the cloud, it's also about developing code together with others in the cloud with help of tools provided by GitHub. And last but not least, GitHub also offers automation services like GitHub Actions that help you automate repository and code related processes. Hi, my name is Max. I'm the instructor in this video, and I just briefly want to mention that my colleague Manuel also created a deep dive Git and GitHub course, which you can use to learn even more about Git and GitHub after taking this crash course, and that I also created a course on GitHub Actions, which you might be interested in to learn more about this amazing service offered by GitHub, GitHub's CI/CD service, which you can use to automate code-related tasks like deployments or automatic testing. And therefore, these would be courses you could check out after completing this crash course. But with that, let's get back into the course and let's get back to Git and GitHub. Now, in order to use Git and to work with Git, you must install this Git tool on your system. And you can simply search for Git to find its official website, which is git-scm.com. And normally, you should already see a download link on the starting page, automatically the right link for your operating system, but you can also go to Downloads here and then pick your operating system to download the correct version. Now, when picking your system here, you typically have different options for installing Git. For Windows and Mac OS, you will find installers, which you can use though, which are simple installation wizards through which you can walk to install Git. And in those wizards, you can simply keep all the default settings, since that will give you Git in a version that works just fine. So make sure that you do download and install Git on your system. And once you did that, you should open up your system terminal or command prompt or shell, and in there type the command git. If you now hit enter, you should see a list of commands you can use in conjunction with Git. If you're getting an error that tells you that Git is an unknown command or anything like that, you should make sure that you finished that installation process successfully. And if you did, you should restart your system to make sure that this Git tool was installed successfully. Now, as you can tell here, you get a broad variety of commands that you can use, and throughout this section, we'll dive into the most important commands. I'll say right away that many commands here are niche commands, which you don't need too often, but we will of course cover all important commands, just as we will cover the most important GitHub features later. So with Git installed, we can now use it. And you do typically use it in your development projects where you write code to build an app or a website or a package. Now, since you use Git to manage your source code for an application or website or anything like that, we need some source code in order to play around with Git. That's why attached to this video, you find an index.html file, which is a file that would display a very simple website, which we will use as a project and as a starting point to dive into Git. You find this file attached, and you should move that file into a folder somewhere on your system, which you then open as a project with your favorite code editor. Here, in my case, I'm using Visual Studio Code, which is an amazing, very fast, and totally free code editor and IDE, which you can download from code.visualstudio.com. It's a very powerful IDE that offers tons of configuration options and extensions that you can install into it, and you can download it for all operating systems on that website. Now, once you did open the folder that contains this index.html file with your favorite editor, you're ready to go. By the way, here I also got a .vs Code folder that holds some project-specific editor settings. For example, the zoom level I set here. You don't need that folder or these settings. I did only add these settings for recording purposes here. So here we got this index.html file, we got our starting project. How can we now use Git with that? When working with Git and when using Git for managing code, it all comes down to creating a Git repository initially. Because all these Git features and commands can only be used in projects that have a Git repository attached to them. And a repository simply is a folder that's part of your project folder that in the end is used by Git to track all your code changes and store all your code snapshots, you could say. It stores all the metadata that's needed by Git to allow you to jump back to older snapshots, for example. And Git commands are only available in projects that have such a repository attached to them. Now, whenever you create a brand new project, it typically doesn't have a Git repository attached to it though, and you can therefore easily create one by running the special git init command in a project folder. That's only required once per project because it's only required to initialize that project and put it under Git's control, you could say. And some projects that you might have created with help of other tools or CLIs might already do that for you. In that case, Git init will tell you that it's not needed anymore though. For example, if you create new React projects, those typically come with a Git repository. But that's not too important here. This starting project here doesn't have a repository attached to it yet, and we can tell that this is the case if we open our system terminal. Here in my case on macOS, it's this default macOS terminal, and we try to run a git command here in this project folder. The nice thing about this integrated terminal here in Visual Studio Code is that it's already navigated into this project folder, so all commands I run in this terminal are executed in this folder. If you're using a different solution, you must make sure that you navigate it into this folder in your terminal or command prompt first before executing any commands. So here I now want to run a git command. And even though we haven't learned about it yet, let's run git add index.html. I'll explain this command later. For the moment, let's just try running this command. And as you will see, it tells me that this is not a Git repository. So that there is no Git repository yet, and therefore this project can't be managed with Git. That's why we need to run git init as a first step, that command I showed you on the slide. This will initialize and create such a Git repository and kind of attach it to this project folder. By the way, this also means that all subfolders of this project are managed by Git. So if I hit enter, this is created, and what this did under the hood is it created an invisible.git folder that holds all that Git relevant metadata. Now that I did initialize this project by running git init, I can use these other git commands. Here in Visual Studio Code with all the default settings, you might also notice that some things changed here, and for example, the text is now green or in some other color. You also might notice that there is a U next to index.html after running git init in this project folder. This is just some help provided by Visual Studio Code, which has a strong Git integration to give you some visual hints that tell you which files are part of which snapshot and so on. You can totally ignore that and you don't need that, but it can sometimes help with using Git. For this course, it's not important that you have this color coding though. So this project was initialized, or Git was initialized. How can we now use Git? As mentioned before already, Git is mainly about those code snapshots, those commits. And the idea is that as a developer, once you made some meaningful changes to your code, once you finished the work on a certain feature or on a bug fix or anything like this, you create a new snapshot, you create a new commit. And doing that is actually a two-step process. It all starts by running git add and pointing at the files that contain the changes that should be included in that snapshot. Because you control which files and which changes should be part of a given snapshot. This process is called staging. You stage the changes that should be included in the next commit. You define which changes should be part of the next commit. This command alone doesn't yet create a commit though. Instead, for doing that after running git add, you have to run git commit. This then creates a commit based on the changes that have been staged. And over time, you can create more and more commits to reflect your different code changes, new features, and various bug fixes you might have implemented. And the idea behind having all these different commits and this history of commits is, of course, that you can then go back to an older commit whenever you need to, for example, to revert a change. But I'll get back to that in a second. So git add and git commit are used in conjunction to create a commit. And we have this separation between these two commands so that you don't necessarily have to include all changes in all files whenever you create a new commit, but you can pick which changes in which files should be part of one snapshot and which other changes should maybe be part of another snapshot, another commit. So back here in our project, we got one file in the end, the index.html file. And since I just initialized this project or this Git repository, the entire file and all its content is new. So the change is that this file with all its content exists. And it makes sense that whenever you create a new project or you initialize a new Git repository, you want to create one initial snapshot that reflects this initial state. And in my case, I want to add all the changes in this folder to this snapshot. And in the end, that means that I want to add the index.html file. Therefore, as we just learned, we must run these two commands: git add and thereafter git commit. Now to add this index.html file to this upcoming snapshot which I want to create, I simply run git add index.html. Now if we had multiple files that should be added, there are various ways of adding all of them. You can, for example, separate them with a white space and then list all the file names if you had more than one file. If files would be in a subfolder, you could also specify that subfolder name and all the files in that subfolder would be added. Now there are more ways of targeting multiple files, and I'll get back to that later. For the moment, let's just add index.html. Now this file is staged. And you can see the current status of your Git repository and, for example, find out which files are staged and which files are not staged by running git status, another key command. This command doesn't change anything, but it gives you some information about the current status of this Git repository. And if I run this command, then I see that in this Git repository, I'm on my main branch, and I'll get back to branches later. This might also say master for you instead of main, but this does not matter. I have no commits yet, and I see that the changes that will be committed in the next commit are this new file that was created, index.html, which is a new file in this project in this case here. And that I have some files and folders which are currently not tracked, so which won't be part of the next commit. In my case, that's this .vscode folder and all the content inside of it. And that is just the way I want it, because I do not want to add this folder or file to this first snapshot here in my case. So now this is staged. This file, or this change to be precise, is staged. To now create that snapshot, that commit, we can run the git commit command. If we do that, though, an editor will open up here in the terminal, because every commit you create needs a message that describes the commit. That message should typically be pretty short and concise, but some message is needed. Now you could use this editor here in the terminal to write that message, but using that in terminal editor could be a bit clunky if you have never worked with it before. Therefore, I'll just close this terminal and open a new terminal here. And instead of running git commit like this, I'll add a special flag, a special option to it, the M option with -M. And then between double quotes, I type my message, like for example, initial commit. And the message should be short, and this flag, this -M flag, is meant to leave short commit messages. So now with that, I can hit enter, and now this first commit was created with that message, and I also see a summary of the commit here, what changed and what was included in that commit. You can thereafter run git log to get a list, a chronologically ordered list of all the commits you have thus far, and at the moment that's just one commit here. You also see the automatically created ID, the unique identifier of that commit. And of course, this will make more sense once we start adding more commits here. You can ignore that part for the moment. I'll get back to this head thing in just a second. Okay, we created our first commit. If we then take a look at the list of all our commits with git log, we see that for this one commit which we have thus far, we also got this head arrow main annotation. What's that about? Well, main is the name of the branch to which this commit belongs or of which this commit is part, and I'll get back to branches a little bit later in this section. This head thing here, though, is something different, because this is basically a pointer managed by Git that controls which commit is currently visible in our project, so to say. So which state is currently loaded, you could say. Head points at the commit that's currently loaded. And that's important because once you have more than one commit, you can also start moving between those commits. You can move between those commits with the git checkout command, which needs the ID of the commit you want to move to. And that command would then allow you to temporarily move to another commit, which means the other commits that come after the commit you're moving to won't be deleted. You just temporarily load another state. And this head pointer simply tells Git which state is currently loaded, which snapshot is loaded. And when using git checkout and, for example, loading the commit C4 on this slide, Git would move this pointer to that commit and would load the contents of all the files that were part of that commit or that made up the Git repository at that point of time into our project. And the other commits and all the changes that were made as part of these commits are still there, they're just not visible at the moment. Now, to see this in action, we need a second commit. And therefore, to make sure that we do have a second commit, I will add another element or some extra code to this index.html file. I'll add such a p element, such a paragraph element as it's called. And there I'll say learn more about Git on, and then I add an anchor tag element which creates a link. The official website, that's what I say between these link tags, these A tags here. And then here I simply point at this URL here. And you find this version of this HTML file attached to this lecture so that you can follow along with ease. So now I made this change and I saved this file. And in Visual Studio Code, you see that the name now turned yellow or orange or golden. And you also see that there is a M next to that file name here. This simply means that this file was modified now, so that we don't have the same state as before in the last commit, but that we changed something in a file. Now, if we want to create a snapshot that includes that change, we must create a new commit. And therefore, that's what I'll do. Now, to create that new commit in my terminal here, I will again run git add index.html, because that is the file that should be included in the next commit. And I know that we included it in the previous commit, but the file was in a different state in that commit. The content of the file was different, and therefore now I'm adding this updated file. And that's important. You add the same file multiple times whenever you change a file and you want to include the changes in that file in a commit, you have to add the file. That's why I add index.html again. Now this file modification is staged. So if we run git status, we can see that this modification is to be committed in the next commit. This change that this file was modified is to be committed. And therefore now we can again run git commit and add a little message where we could say added link to git docs or anything like that. If I now hit enter, this commit is created. And now when you run git log again, you see that we have 2 commits here, which makes sense, hopefully. You see that the head pointer points at the latest commit, because that's something Git does automatically. Whenever you create a new commit, this head pointer points at that commit automatically. But now let's say we want to take a look at this old version of the code to see what was changed or to see that original state. To do that, we have to grab the ID of that commit we want to go to, so of that initial commit here. And then we can run git checkout and add that ID thereafter. And if we hit enter, you will see that up here, the code changes. The paragraph that includes the link is gone because I'm now looking at this old version of my project of that code again. Now, as mentioned before on the slide, the other code, the more recent code, isn't lost. It's still stored by Git. It's just currently not loaded into this project. So that's how we can move to this old version. If you run git log again, we see only one commit, the initial commit, because git log by default always logs all commits that are older than the commit we currently checked out. You see that the head pointer now points at that commit, but you see that this main part from before is gone. The reason for that is that this is now basically detached. Git has this branches feature, which we'll explore a little bit later, and our commits belong to different branches. If we then check out a commit, this commit is basically loaded outside of a branch, which is why the branch name, which is main in my case here, is not displayed here anymore. If I want to get back to my branch that includes all the commits, including the commit which I'm now not seeing anymore here, I can simply type git checkout main, so the name of that branch, which I know includes all those commits. If I do that, you see the paragraph with the link is back, and with git log we see all commits again, and we see that now the head pointer points at that latest commit in that main branch again. So that's how we can move around with git checkout, and as you can see, this is all just temporary. We don't delete anything if we check out an older commit, we just load it temporarily, and we can always go back to the full history, to the full branch, which includes all these commits that belong to it, by checking out that branch again. Okay. So at this point, we now know how to create commits for a single file at least, and we learned how to move between commits. Now, let's say that we want to undo this latest commit. We're not happy with it anymore. We don't want this paragraph. Instead, I want to add some styling to this website, and I want to add an image to make it look more pleasant. Because at the moment, if you open this in your Finder or your Windows Explorer, and you double-click that index.html file there, you will see that this website doesn't look too fancy. So I want to add some styling and a nice image to it, and I want to get rid of this paragraph with this link, because let's say we don't need that anymore. How can we revert such a commit then? Well, one option would be to manually make the changes we want to make, like for example removing that paragraph and then adding a new commit. That is something you can do, and that is absolutely fine. But it's actually more work than you need to do, because Git also offers various commands that help with undoing commits. For example, the very important git revert command. This also needs the ID of a commit you want to revert, and what this command does then is it takes a look at the commit with that ID that you're specifying here, and it then reverts the changes that were made by that commit. So not all the changes since that commit, but the changes that are defined in that commit with that ID. Now what's important is that git revert won't delete that commit which you want to revert, but instead it adds a new commit in addition that includes all the changes that have to be made to undo the changes of that other commit. To see this in action, I'm back here in my project, and I know that I want to undo this commit, because that's the commit where I added this paragraph. In order to do that, I'll copy the ID of this commit. And then I can run git revert and specify that commit ID. If you do that and you hit enter, you see now the paragraph with the link is gone, and I'm prompted to enter a message here. Now I have to enter a message here because I'm basically creating a new commit here. That's what I just explained. It's reverted by adding a new commit. So therefore here we have to enter some content, and how you enter your content here, how you use this terminal editor depends on your operating system and what your default editor here is. So that's something you'll have to look up for your specific editor in your command prompt. Here I'll just say reverting added link, and thereafter I'll save and close this. And now if I run git log, we see that the old commit where I added the link is still there, but we also got this new commit, which I just made, which gets rid of the paragraph again. So that's something Git did automatically for us, and we didn't have to edit the code manually. Of course, when it comes to removing a simple paragraph, manually editing the code is something that wouldn't have been too difficult, but in bigger projects you will often have changes that span multiple files and are more complex, and then it's of course very convenient if it's just one command that gets rid of all these changes, instead of having to do that manually. So that's how you can undo commits with help of git revert. Now git revert is one option, and typically it should be the preferred option since it keeps the history of commits clean and you're not starting to rewrite history. But sometimes you really want to delete a commit, you want to get rid of a commit, and you can do that with the git reset hard command. This also needs the ID of a commit, but here it's the ID of a commit you want to go back to. And all the commits since that commit you want to go back to will be deleted. That's what git reset hard does. And you should be careful with that command because you can't really get back those changes that were made after this commit once you executed that command. And you're also rewriting history. And with Git, the idea really is that you never lose any changes or state, but you just keep on adding new changes. With git reset hard, you're actually losing something, and therefore it's not something you should use all the time. Nonetheless, here I could, for example, go back to the state where I have this link by using git reset hard and pointing at this commit, or go back to my very first initial commit by copying that ID and running git reset -- hard and then using that commit ID. If I hit enter here, you see that now after running git log, I have only one commit left, which is my initial commit. I really got rid of my commit history and all these other commits. Again, that works, but you should use it with care. And that's it for all these key commands you should know when working with Git, at least if we ignore branches, which is another key feature we'll explore in the next minutes. Before we take a look at branches, there's just one other commit-related feature that I also want to explore, and that's how you can commit multiple changes in multiple files at once, and how you can still make sure that certain files or folders are always ignored. Now back here in this project, you might have noticed that at least here on my system, I never committed this .vscode folder. Now, you might not even have that folder, and I mentioned before that you don't need it. It only contains some settings for this code editor on my system, and these are some settings I want to use for recording this video. Now, what's important is that this folder and the settings file inside of it doesn't really belong to this code project. These are my specific settings which I want to use. If I share that code with other developers, they don't necessarily need those settings. So therefore, I don't want to include those settings into my code base, and that's why thus far I always just committed this one single file and I never included this settings folder in my commits because it's not part of the code base. Now let's say that we're adding a couple of files to this project. And as before, you'll find these files attached. Attached, you find a logo.png file and a styles.css file. You also find an updated index.html file, which you can use to replace your file with it, or you just copy this link and this image element from the attached index.html file into yours. That's the alternative. With all of that, the index.html file was edited, and the logo file and the styles file was added. The advantage is that if you would now reload this website, it looks much nicer because of that image that was added and because of the styling. But this is not a web development course, it's just a side note. Since all these changes were made, we probably want to create a new snapshot, a new commit. And I want to include the index.html file, the modifications that were made to that file, just as I want to include these two new files. For that, we can open this terminal again, and we can of course run git add and add index.html, and then a white space, add the styles.css file, a white space, and then logo.png. But this isn't getting us anywhere. This will quickly become a long list of files here, and especially in even bigger projects, it would be super annoying if we had to add all files manually. It's good that we can add individual files, because sometimes not all files should be part of a commit, but you don't always want to target files individually. That's why it's good that git add, for example, also takes the name of a folder, if you wanted to include all files in a folder. Or you use a star or a dot to include all files in your project, including all files in all subfolders. However, here I don't want to run this command just yet, because it would also include my .vscode folder. You might not have that folder, but you might have other system or editor specific folders or files. So I want to be able to target all files and easily stage them, but at the same time there should be some files that are always excluded. And this is such a common scenario and use case and problem that Git supports a special file which you can add to your project, a .gitignore file. And this file must be named .gitignore. The leading dot is important. This file allows you to specify folder and file names of folders and files that should always be ignored when you run git add. In my case, I would add .vscode here to tell Git that this folder and all the files and folders inside of it should always be ignored when I git add all my files or any files or folders that include that folder. I will also add a .dsstore file here, because that's a special file that's created on macOS, which is invisible, but which I know that exists and which I also want to ignore. With that, I save .gitignore. In Visual Studio Code, you see that .vscode gets grayed out, because Visual Studio Code understands that I'm ignoring this and that it's not tracked with Git anymore. And now if I run git add dot, I will stage all files, all changes in all files, but .vscode is ignored. If I run git status, it's also ignored here. Here I just see that all relevant files and modifications have been staged. So therefore now I can commit and create a new snapshot, and here I can say added logo and styling. If I hit enter, this commit is created and the VS Code folder will be ignored. And that's the last important fundamental piece of knowledge you need when getting started with Git if we ignore branches. Being able to stage and commit multiple files at once whilst still ignoring some files is crucial, especially when working on more complex projects. In the previous lectures, we learned a lot about basic Git features, and we learned a lot about commits, moving between commits, and so on. Now, one key feature is missing though, and that would be branches. Now, Git branches are a key concept of Git, and they're just as important as commits. Thankfully, though, they're also related to commits, so it's not something brand new in general, but instead a feature that builds up on this snapshot and commit idea. But what are branches all about? Well, as you're working on a project, you start collecting commits, you could say. You commit your various changes, as we also did it in the previous lectures, and eventually you have more and more commits. And these commits are organized in branches. And you got one branch out of the box without doing anything. The main branch, it could also be called master branch though. But you do have this default branch because that branch is created whenever you initialize a new Git repository and you start creating snapshots, commits. And that main branch is what you see when you run git log. Here you see all your commits and you also see this name of that default branch which you have. And those different commits which you created are organized into that branch. So you could say branches are containers that contain commits. But I'm saying branches instead of branch because you can have more than one branch in a project. You can create additional branches, for example, to work on a new feature or a bug fix without immediately impacting your main code. Let's say in this project here, we want to restructure the content of this website, the code of this website. We want to add some new wrapping HTML elements, and we want to add some additional elements. We want to do that without impacting our main work in the main branch, which might focus on maintaining this current state and just fixing bugs related to that website. We only want to apply our changes once we're done with all the various code changes that are involved in that new feature which we plan to add. Of course, here for this dummy example, we won't add too many new features, but in more complex projects, you could easily spend a couple of days working on a brand new feature. And you want to work on that feature in a place where you don't interfere with your colleagues that might still be working on the old code and might be fixing bugs there. That's why you can create branches. You could, for example, create a new feature branch by running this git branch command, which is offered by Git. By default, this command takes the latest commit, which is currently targeted by head, and it builds a new branch with this commit as the starting point. Now, all the old commits are also taken along, but this commit is now the starting point of this new branch. So the same commit is now part of multiple branches. Now you could still continue work in the main branch and, for example, create new commits there, but those commits would then not be part of that other branch of the feature 1 branch. On the other hand, you could also add commits there in that branch without immediately affecting the main branch. And that's what I mean. Different teams could, for example, work on different branches so that they can work on their different features or bug fixes without interfering with each other. Now, eventually, of course, you might want to combine all these code changes though, because if we stick to the example of a website, the goal is, of course, not to build multiple websites, but to still work on one single website, just on different features or bug fixes that are all relevant to that same website. And that's why eventually you can merge those different branches with the git merge command. If you run that command, all the commits that are part of one branch, of the feature 1 branch, for example, will be merged with the commits of the main branch. And Git will automatically try to commit those changes such that nothing is overwritten. If you do have clashing code changes though, you might need to resolve those problems manually, but that's something we cover in greater detail in our complete Git course. It's a little bit too advanced for this crash course. In many cases, the automatic merging works just fine. So that was the theory. Now to come back to our example project here, let's say there we do indeed want to restructure the HTML code a little bit. And I want to do that in a new branch so that I can continue working on the old branch without clashing with the other upcoming code changes. To do that, we have to create a new branch. Now, this can be done by running git branch and then the name of that new branch you want to create. In my case here, I'll name it feature-restructure, but the name is up to you. It should be one word though, and it's quite common to use all lowercase characters and separate multiple words with dashes. So here it's feature-restructure, and if I hit enter, this branch was created. You can view all branches. You can get a list of all branches that do exist in your Git repository by running git branch without a branch name. If you run it like this, it simply lists all existing branches. And here you see that we have the main branch and the feature restructure branch. This command, git branch, also shows you which branch is currently active, so in which branch you're currently working. It highlights that branch by coloring it and adding this asterisk next to it. So here I'm still in the main branch, I just created this branch here. If we now want to work in that branch, we have to check out that branch by using the checkout command which we saw before. Before we used it with the commit ID, now we're using it with a branch name to switch to that branch. If I do that, you see that I switched the branch, and if I run git log there, you see that we have the same commits as we do in the main branch in this branch here. This is also something that we can see up here where all the branches are listed. So all these branches contain this commit and also the older commits here. So now we got two branches that build up on the same commit. There also is a different way of creating that branch though, which saves you this extra checkout step in case you know that you do want to move to that new branch right away. For that, I'll first of all go back to the old main branch, so that this is the active branch again. And now we can delete the newly created branch by running git branch -D and then specifying the name of the branch that should be deleted. So this git branch command can be used for listing branches if you don't add anything else, for creating a new branch if you specify the name of the new branch, or for deleting a branch if you specify the name of the branch that should be deleted and you also add the -D. So if I hit enter here, this branch is deleted, as you can also see if I list all branches. And now a different way of creating a new branch and automatically checking it out is to run git checkout -B and then that branch name of the newly created branch. So now with that we create a branch and check out that branch in one step, as you can tell if you run git branch again. It still is a branch that has all the commits of the other branch. So that's how you can work with branches in general. Now let's see how we can work with commits in those different branches. Now, as mentioned before, I did create multiple branches here so that we can work on a new feature without directly influencing the existing code in the main branch, which often is the branch that is responsible for the currently published and deployed website. And we want to make sure that we don't accidentally deploy a half-finished feature. That's why we use a separate branch for that. So here I am in the feature restructure branch, as you can tell if I run git branch. And now I want to apply some changes. Some changes which I prepared in advance. You find a new index.html file attached, and you can simply take the content of that attached file and replace your index.html content with that content. It's relatively similar, but it has a slightly different structure and a new paragraph with some links that allow you to dive deeper into Git. That's one thing that changed. You also find a new styles.css file attached, and you should also take the content of that and replace your styles.css file content with that. It simply adds this link styling. That's the only thing that's changed. With that, if you would view this page, it looks like that in the browser. But that's not too important right now. Instead, this is the new feature we're working on. And here I did it all in one step. If this would be a more complex project and a more complex feature, we might of course work multiple days on that new feature, and we might be creating multiple commits along the way, step by step. Here it's just one commit which I want to add, which includes all these changes to styles, CSS, and index.html. Therefore, I'll stage all my files that changed by running git add dot. Alternatively, as you learned, you can also target them separately like this, but this is quicker. And then I commit them and I'll say added links and restructured page. Now we can see, if we run git log, that we got this new commit here in our feature restructure branch. Here we can also already see that the main branch is one commit behind. It still has the added logo and styling commit as the latest commit. So only the feature restructure branch has this new commit. If we therefore actually check out the main branch again by simply running git checkout main, you will see that the code changes. All our changes are gone. But they're not gone because we deleted or reverted them. Instead, they're still there in their commit in a different branch. But here in this branch, the main branch, we don't have those other commits. We don't have that latest commit. In that main branch, however, we can continue our work and we could work on a bug fix. For example, we might want to add an exclamation mark to the title here. So here in the main branch, I can then also add a new commit by staging all files. In this case, only the index.html file, but still git add dot can always be used. And here I'll say changed title. With that, I got a new commit here in the main branch, which is not part of that other branch we worked in a couple of seconds ago. But now let's say we're done. We fixed some bugs here in the main branch, and we also added this new feature in the feature restructure branch. If I quickly check out that other branch again, you see that there the exclamation mark is gone, because that change was only applied and committed in the main branch. But we do have that restructured code and those extra links here. If we now want to merge those changes from that feature branch into the main branch, because we're ready to publish these changes, let's say, we can move to that main branch and use the merge command provided by Git. So for that, let me shrink this a little bit and watch this body code here. We simply run git merge, and now we specify the name of the branch that contains the changes that we want to merge into this main branch. And what this merge command will do then is it will simply take the latest commit and all the other commits up to that commit in that other branch, so in the feature restructure branch in this case here, and append them to the commits in this main branch. And Git will automatically try to resolve any conflicts it might encounter. For example, here, in both branches, we added the index.html file, but Git will be able to resolve such basic conflicts. If I hit enter here, it therefore performs this merge, and you see that it did indeed change the structure and add those links here, but it also kept the exclamation mark in the title. That's what I meant. We had two commits in different branches that changed the same file, but Git was able to resolve those problems. Now what you also see is that we have to add a message here, a commit message, because this merge is technically a brand new commit that's created here. And therefore we have to add a message, a description to that commit. We get a default description here, which says that we merged this, and we can simply accept this message by saving this message as it is suggested. And how saving works, again, will depend on which editor you're using here in the terminal and which operating system you're using. Here I confirmed this, and now we're getting a little summary of the merging. It was merged automatically. For more complex merges, you might have to do some manual conflict resolving, but that's something that's covered in greater detail in our Git course. Here it was merged automatically. We see which strategy was used by Git because it knows different strategies, but that's also not too important here. And we see which files were changed. We see that a lot of additions were made to index.html and some things were removed. And we had some additions, 4 lines that were added, to be precise, that were applied to styles.css. We also get a summary here. Now, as a result, we have our exclamation mark in the title, and we have our links and the changed structure in the body element of index.html. If we now run git log again, we also see that here we have the commit that performed the merge, and we got the other commits from both the main branch, this commit here, where we changed the title, and from the feature restructure branch, where we added those links. And that's, by the way, still the latest state of that feature restructure branch, as is indicated by this marker here. Since we merged feature restructure into the main branch, the feature restructure branch was not changed. There, this exclamation mark won't be there, this exclamation mark in the title I mean, because we merged feature restructure into main, not the other way around. We could have done that, but we didn't. And indeed, if I quickly go to the feature restructure branch here, you will notice that there we have the same state as before. Links and changed structure are there, but the exclamation mark is missing. But that's exactly the idea. Now we merged those changes into main, and since we're done with our work on this new feature, we could of course therefore simply get rid of that feature restructure branch by running git branch -D feature restructure. That deletes this branch, which we don't need anymore. Of course, the changes which we merged are still there because we did merge those commits into main. And that's how we can work with different branches to work on different features simultaneously, only combining these features when we're ready for it. So we used Git locally on our machine, and that's the idea behind Git. It is a tool you use locally on a machine. We created commits, worked with branches, and now we have this history of commits here. Now, of course, if you're only working locally with Git, that has a couple of disadvantages. For example, if your computer crashes and you can't recover it, your data, and this includes your development projects, will be lost. Collaborating with team members or colleagues is also unnecessarily hard because you basically need to manually copy the code across different machines, for example with USB sticks or as attachments on emails or anything like that. And the same is true if you ever need to switch machines. If you are traveling and you have a different laptop with you than you normally use for development, you don't have immediate access to your code. That's why we have GitHub. GitHub has the term Git in its name, but the company doesn't own the Git tool. Git is an independent tool and GitHub is an independent company. But GitHub is a company that's built around Git, you could say. It offers various services related to Git, and most importantly, it allows you to store your Git repositories, and therefore your code, in the cloud in so-called GitHub repositories, which are simply code storage buckets, you could say, created in your GitHub account. And if you're using GitHub and those GitHub repositories, then you can store your code there and use that as a backup strategy, but you can also easily share it with other users or with yourself on a different device. In addition, GitHub also offers many other services that make project management, bug tracking, and automation a breeze. It's also worth noting that GitHub isn't the only company providing these kinds of services. There are other companies as well, like GitLab, which sounds similar but is a different company, but we'll focus on GitHub here. Now you learned what GitHub is and why using it could be useful, for example, for backup purposes. Now the key feature offered by GitHub is its repositories feature. You can create those cloud storage buckets in your GitHub account and then connect your local Git repositories to those GitHub repositories to back up your code or use it across different devices and so on. Now, when you create a repository, you have the choice whether it should be public or private. As the names indicate, public repositories can be viewed by everyone, private repositories can't. Either way, not everyone can write to them. So even if a repository is public, this does not mean that all kinds of people can start editing your code. That's not the case. Instead, public and private only controls who's able to see and view a repository. Editing the code in a GitHub repository is a totally different thing. But before we dive deeper into GitHub repositories, let's first explore how we can create such a repository. And for that, you first of all must create a GitHub account. Now for that, you can visit github.com and then sign up. Of course, you can skip that if you already have an account and use that account instead. Now here, you simply enter your email address and of course your password. Then also a username, which is of course up to you, but must be unique. So you might need to try a couple of different usernames before you have a fitting one. Here I'll choose N for no. And then you might have to solve a brief puzzle to prove that you're not a bot. With that, the account gets created and you just need to verify it by entering a code that's sent to you via email. Now, once you finished the account creation, you can choose which parts are most interesting to you, but you don't have to make a choice here. And then you're presented with different plan options, because you can use GitHub for free, but you can also pay for it to get more features. Now, to get started, the free plan has everything you need, but if you're working in bigger teams and you need advanced features, those paid plans might be very interesting to you. Here, for this account, I'll continue with the free plan though, but it is worth keeping in mind that you do have those paid plans if you need them. Now, once you created your account, you should be greeted with a page that looks something like this, though the exact content will change over time. Now, GitHub offers tons of features and you can dive way deeper into all these features with the official documentation. You can, for example, create and edit your own profile page, which could help you apply for jobs. Now, we are interested in this repository feature though, and therefore the first thing we'll do is we'll create a new repository. So we want to create a repository, and we can do that here from that starting page, also by clicking this button, or by clicking on our profile picture in the top right corner and going to your repositories, and then there we can also create a new one. So there are many ways of creating such a repository. When you create it, you have to choose a repository name, and every repository name in your account must be unique. Here I'll name it GitHub Crash Course, but the name is up to you. You can then also add a description, and then you have to choose whether it should be public or private. And I explained before that this controls who can see your repository. It also says here that you still choose who can commit, so who can edit the code. So even if you choose public, this does not mean that everyone can edit it. Here I will pick public, since this will simplify a couple of other things I want to show you later in this section here. Now, if this would be a brand new repository, which doesn't exist locally yet, then you could also choose whether you want to initialize it with a gitignore file, which we did add in earlier videos manually. You could choose to add a README file, which explains extra information about your project and your repository. And this can be useful if you do want to share it with people from all over the world, and those people should understand what your project is all about. And you can add a license where you essentially define how your code may be used by others. Here I'll choose none of that because we already do have a local Git repository which I want to connect to this newly created cloud repository here. Therefore, I'll just click Create Repository like this. And that's how you do create such a cloud, such a GitHub repository. How can this now be connected to your local Git repository though? Once you created a GitHub repository, no matter if it's public or private, you connect it, so to say, to your local Git repository by running the git remote command. To be precise, the git remote add command typically. This adds a remote repository, like this GitHub repository, to your local repository. It establishes a connection. You can then thereafter start pushing your local commits to that cloud repository so that they are stored there. And since these commits include all the code and code changes, your code is effectively stored in the cloud, so on GitHub. And you can download commits which you don't have on your machine yet with git pull. And we'll see these commands in action throughout the rest of this section here. Now, I did create this repository here, and at the moment it has no content. I do have my local Git repository here though, which does have code and content. In order to connect it, we must run git remote add. But this alone is not enough. You first of all need to give this GitHub repository a name, a local name. Now, you can choose any name you want, but a very common name is origin. You'll see that in almost all local Git repositories, and therefore I'll also use origin here, but again, you can use any name here. This is just a local identifier of this remote repository. You also, and that's very important now, must provide a URL to that GitHub repository or to that remote repository in general, since GitHub, as mentioned, isn't the only provider. And that's the URL GitHub is showing to us here. You can grab that URL, so you can copy it, and that's the URL you have to paste in here for this git remote add command. This command, git remote add, will then add a new link, a new connection, you could say, to this remote repository here, and this will be the local identifier. Origin will be the local identifier, which we need later to push our commits to that remote repository. And you could add connections to multiple remote repositories by simply using different identifiers with git remote add. Now here, if I hit enter, this adds this connection. And now we could try to push our local commits, our local code, to this remote repository. We'll do that next. So how do we now push our local commits to this remote repository? Well, for this we have the git push command. However, if you execute it like this, you get an error. You get an error that the current branch has no upstream branch, which simply means Git doesn't know which branch in the remote repository belongs to this local branch. And keep in mind, here I'm on this main branch. Now, in order to establish a connection between these branches, we can execute this command. Alternatively, if it's a one-time push and you don't want to establish such a connection, you can also simply run git push origin. So here you simply reuse this identifier which we specified before. And then after that, you specify the name of the local branch that should be pushed to this remote repository. And then there, it will target a branch of the same name. And if this doesn't exist yet in the remote repository, it will create that branch. So when I run git push origin main for the first time, this will create a main branch in this remote repository and push my commits of my local main branch to that remote main branch. However, still, if I execute this, I get an error, a permission error. And if you think about it, that should make sense. How would GitHub know that the person pushing here does have access permissions? We know that it's our repository, but what if I had a link to your repository? I could simply push to it and overwrite your code. And getting that link here isn't difficult, because this link can be grabbed by everyone who visits your repository page. If you take a look at this link, it's also not too difficult to construct because it's essentially the URL up here with .git at the end. So this link is definitely not secret, everyone can grab it, and therefore by default you have no permission to push to that link to that repository. How do we then authenticate ourselves? Well, one common way is to set up this remote connection slightly differently. We still grab that link here, but now we use git remote set-URL. So we use this command to edit the URL of our origin remote repository. And in front of the word github.com, in front of this part of the URL, you add your GitHub username, which you chose when you created this account, this GitHub account, and then an @ sign thereafter. And this will tell GitHub that whenever you're interacting with that repository, this user here should be assumed. This will then still not be enough, but it will be a first step. Of course, we could have also done this when we added the origin, but I wanted to show you this permission error. That's why I'm now using the set-URL command to update the origin URL. So if I do this and I then repeat this git push origin main command, I get a prompt here in Visual Studio Code to enter a password. If you're not using Visual Studio Code, you might also get this prompt in the terminal here in your command prompt. And here we should use a so-called personal access token to authenticate this request. The username alone is not enough, and it's a good thing that it's not enough. Instead, we also need a password. And this personal access token can be created here in your GitHub account by clicking on your profile image and going to Settings. And there you got a lot of things you can configure. It's definitely worth diving into all these settings and looking through them, but we need to go to Developer Settings here. And under Developer Settings, we have to go to Personal Access Tokens, and there we must generate a new token. Now you can give this any name of your choice, and you can choose how long it should be valid, and then you must check Repo here. This means that this token can be used for actions, for commands that target repositories, like pushing or pulling. If you choose this and you fill out these fields as mentioned, you can ignore all the other settings, you can generate that token, and now you must copy that token. You will only see this token once, by the way, but you can always generate a new token if you lose it. But with this token copied now, you can paste it into this field or into the command prompt, wherever you're prompted for it, and hit enter. And typically your operating system should automatically store this token then so that it's automatically used for future requests. So now once a valid personal access token was provided, you see here that the push succeeded and we get some summary output. If you go back to your repository, by going back to GitHub, your repositories, and then that repository, you now also see that that code is here. And that's how you can push your code to your GitHub repository. Now, as mentioned before, always typing this command can be cumbersome, and this doesn't work yet. Therefore, you might want to copy this suggestion here, this command, to configure a strict connection between your remote repository and its main branch and your local main branch. If you run this command here, it's thereafter enough to just run git push to push your changes off the main branch to the remote repository. In this case, nothing is pushed because I haven't changed anything locally. So we did now push our main branch to GitHub. Now let's say we're developing a new feature or a bug fix, and therefore we're creating a second branch. Let's say what we want to do here is we want to group these paragraphs into a section. It's of course a trivial change and wouldn't require a separate branch, but it's just a demo. So here I want to create a separate branch, and therefore, just as you learned it before, we can create such a branch with the git branch command, or if you want to check out that branch immediately by using git checkout -b and then the name of the new branch. And here I will simply name it feat, short for feature, section. If I hit enter, this branch is created and we automatically switched to it, as it's also saying here. And now we can make that change that should be made, which in my case here simply means that I add this section and I wrap this around these two paragraphs like this. So that's my change now. Again, a trivial change, but good enough for this demo. Now, after saving this file, I want to stage this change and I want to create a new commit, a new snapshot, but I want to do that in this separate branch because maybe the feature isn't fully finished yet, or for other reasons, we're not quite ready to merge it into the main branch. Therefore, again in the terminal, I will stage all files or just the index.html file, does not matter since it's the only file that changed. And then I create my commit where I say added section. That sounds like a good description for this change. So now we added this commit to this branch, to the feed section branch. And now I also want to push this branch to my remote repository because I want to have that code on GitHub as well so that it's backed up. I could work on it from different machines and so on. Therefore, what I'll do is I will git push to my origin, so to this remote GitHub repository, and I'll push this feed section branch. It's the same command as we used it before, and alternatively, we could also use this set upstream approach from before, which we used for the main branch, for this feed section branch as well, so that in the future, all we have to do is run git push whilst being in that branch locally. Here, I'll use this slightly longer form though, confirm this, and this now pushes this code to this remote repository. Now, on this remote repository, we should immediately see a little message here. And if you reload this page, this dropdown here now also shows you this second branch. And on GitHub, you can then also switch between these branches. We can, for example, select this branch, and if we have it selected in this code, which we can browse on GitHub, we see this change with the section being added. If, on the other hand, I switch back to the main branch, we see that for the index.html file, this section is not there. And that's, by the way, also important. On GitHub, you can browse this code. You can even edit this code from GitHub and merge it with your other code from there. We're not going to do this here, but you could do that. You might also notice this compare and pull request button, which I have here, and I'll get back to pull requests a little bit later because this is a key GitHub feature, but I'll get back to it in the future. So now I have my branch here on GitHub. If I am now ready to merge this feed section branch into my main branch, we could do this from inside GitHub, but I will do it locally here by again checking out my main branch and then running git merge feed section. Now this is merged automatically again, and we get a little summary here. And now, of course, I can run git push to push this updated main branch, which has these merged changes, to GitHub. Here, by the way, no separate commit was created, and I didn't have to confirm or enter any commit message after performing the merge, because Git was able to perform this merge by simply appending this new commit to the other commits instead of creating a new commit. It simply depends on the complexity of changes you have and whether there are any clashes that must be resolved by Git, whether you have to create a separate commit when merging, or if a commit from another branch can simply be appended to the commits of the main branch. So now I performed this merge and I pushed my updated main branch, and therefore, of course, this is also reflected on GitHub. Here in the main branch, if I inspect index.html, I also see the section here. But that's how we can also push multiple branches to GitHub. By the way, if you then have a branch on GitHub which you don't need anymore, like this feed section branch, you can also delete it from there by clicking on View All Branches here, and then there you see this feed section branch, and if you click this trash icon, it will be deleted. You could now also restore it, but now it's gone from GitHub because we don't need that branch there anymore. It still exists locally, as you see if you run git branch, but of course there you can also delete it with the command I already showed you earlier in the course, with this command here. So that's how we can work with multiple branches and GitHub. Okay, so now we pushed some code and also different branches to GitHub. Now, one thing you might notice here on my screen is that GitHub also tells me that I could add a README to this page. And a README is simply a file with some extra information about this repository. This extra information can help your co-workers if that's a private repository. It could help you in the future if you're coming back to this project, or if you're doing some open source work and you're sharing your code with the entire world, then such a README file could provide some helpful instructions and information to all the visitors that might be visiting your repository and that might be using your code or package. Now, adding such a README is simple. You can do it locally by adding a readme.md file, and you don't have to use all caps here. This is just a convention. Alternatively, you can also create it here on GitHub, and then GitHub will automatically merge it into your branch. And I'll do the latter and create this file on GitHub, because that then also allows me to show you another key feature when it comes to working with remote repositories. So if I add a README here, then this editor opens up. And this editor uses Markdown for structuring the content. And you would use Markdown locally as well. Your README file does have to be a .md file, which stands for Markdown, and which is a special language or syntax you could use that allows you to easily write structured and rich text. Now, if you don't know how Markdown works, the official GitHub documentation gets you started if you search for GitHub Markdown. And in this article, you learn how you can format your text and structure your text with Markdown. For example, you create a heading by adding a hash symbol here. And then we could say important instructions, and then add some plain text where we, for example, say this is a demo repository for practicing Git and GitHub. And there are more features you can add with Markdown, like lists or code snippets. And again, this article gets you started and tells you how you can format and structure your text with Markdown. Here, I'll just add this dummy README. We can also preview it and see how this will show up on this GitHub page once it has been published. And with that, here, I'll just add a little instruction. Added README as my extra message here. And now we commit directly to the main branch. So that's what I meant. You can also create commits, which are then added right here on GitHub. And that's what I'll do here. I'll commit this file. And now you see that in this main branch, we have this readme.md file, which contains the content we just added. Here we get the preview, but if I look at the code version, then we see the code we just wrote. So that's how we add this README. But now we have a problem. This README file, with instructions that also show up down there, exists on GitHub, but it does not exist in our local Git repository. And of course, if we continue work locally, we would therefore continue working on a different version of that code. And ultimately, if we then push again in the future, this would lead to problems because we would push outdated code to GitHub, because our code, our project, would be missing this readme.md file. So we need some way of downloading the latest code from GitHub to our local Git repository. Now, in order to download code from GitHub to our local Git repository, there is a useful command we can run locally. And that command will be very important because here we created a README file on GitHub, but it's of course also possible that you maybe pushed some updated code to this repository from a different device, or that you're maybe working on this code in a team and a colleague of you changed the code and you want to download that latest version that's on GitHub to your local repository so that you can continue work. And in order to download code from GitHub, all you have to do is run git pull. Git pull does what the name kind of implies. It downloads the code from GitHub and applies it to your local Git repository. So here, if I run git pull with my remote repository linked, which we did way earlier in this course here, I now see that some code was downloaded. You get a summary here, and you see that in the end, it updated this readme.md file. And indeed, the readme.md file is now showing up locally, and in it, we see the content that we wrote on GitHub. So now we have the latest version of the code on our local machine again, and that's of course important because now we're making sure that we're working on that latest version of the code again. So if we would now make changes here locally and then push them to GitHub again, we would make sure that we're not pushing outdated code. So by now we got some practice when it comes to working with GitHub and remote repositories. Now, as you can see on this repository, there are many tabs we could dive into here. And this is not an advanced GitHub course, that's why I'll not dive deeply into all these tabs here. The Actions tab is for GitHub Actions. Issues and pull requests will also be covered later. The Projects tab would allow us to set up a project here on GitHub and actually organize our next steps and use GitHub as a project management software almost. The Wiki tab allows us to set up a wiki that belongs to this repository, which can be useful if we're doing open source development and we want to add additional FAQs or instructions or help. The Security tab allows us to set up various security settings and also provides us with reports about possible security issues with our repository. Insights gives us some analytics for this repository, and Settings allows us to set all kinds of settings for this repository. We can change the name, we can change the visibility, and for example, turn a public repository into a private repository if we wanted to, and do many other things as well. GitHub is quite an advanced service with many features, and it's way beyond the scope of this course to dive into all these features here. Many features are also only helpful in certain, possibly niche scenarios. For the moment, I want to focus on something different instead. Let's sign out of this user here, and let's take a look at this repository as an anonymous user. So I'll copy this link here in the URL and sign out, and then go back to the repository. We can still view it even without being logged in because it's a public repository, as you can see here. Therefore, even if we're just visiting GitHub as an anonymous user and we're not logged in, we can browse that code. Of course, we can't change the settings. That's why we no longer have this Settings tab here. And we also can't change the code from inside GitHub here anymore, but we can browse and view the code, and we could also browse multiple branches if there would be multiple branches. Now, let's say we're interested in this repository and the code in there. We want to take a closer look at it, and maybe we even want to help with development. Therefore, chances are high that we want to download this code to our local machine. Now, for the following steps, I'm simulating that I'm a different person with a different GitHub account working on a different machine. To simulate this, I'll create a second GitHub account with a different email address. And I'll again use the free plan for that. And after creating this GitHub account, I'll also edit my local Git configuration to make sure that this Git account is also used when I push to GitHub and so on. And I'll do that by using the git config command with the -- global flag. And then I'll set my username to the username I used for this new GitHub account, though you can use any name here, including your real name. And more importantly, I'll set the email address of my Git user on this system to this email address I used for this second GitHub account. And that should be that email address you used for that second GitHub account, because that will make sure that your commits will be linked correctly. So let's now assume we're a totally different user on a different machine, and we want to help develop this application or website. We want to help with writing that code. If that's what we want to do, there are different ways of downloading that code to our local system. But it all starts by clicking this code button. Now we could download the code by downloading it in a zipped version. That would then give us a folder that includes all these code files. But if we have Git installed, there actually is a better way of downloading that code and setting up a project that already has a link to this remote repository for possible future pushes. For that, we have to copy this URL, which we get here, in this input field with the .git at the end. That's important. We copy that. And now in a terminal on our system with Git installed as mentioned, we can run the git clone command and add this URL to clone this remote repository onto our local machine. So to, in the end, create a new project on our local machine that contains all the code from this remote repository and that comes with an automatic link, an automatic connection to this remote repository so that we don't manually have to set up such a link as we did earlier with git remote add. We won't have to do that if we clone a repository. Now you can add another value after this URL separated by a blank, which is then the name for the folder that should be created that holds this remote repository code. If you don't specify a name, this repository name is used instead. So GitHub Crash Course in my case here. Here I'll specify my own name, which is git-demo. You can use any name, of course. If you now hit enter, this code is downloaded onto your local machine, in my case into a Git demo folder, and as I mentioned, a link to the remote repository is set up for you. And you can do this without being logged in or anything like that because this is a public repository. Now I opened this Git demo folder in VS Code. So this is now not the old project in which I worked before in VS Code. Instead, this is the clone project, as you can also tell by the fact that the .vs Code folder is missing. It was there in my other project on my machine, but since we're now simulating that we're on a new machine and I cloned this repository and I opened this cloned project folder, this .vs Code folder is missing because it was not part of this GitHub repository. Why was it not part? Because it's ignored by Git. It was never committed. That's why it's not part of the repository and not part of the cloned repository. I could now set my own settings and add my own .vs Code folder here if I'm using VS Code for editing, but I don't get the folder of the person who originally pushed to this repository. And that's of course important and hopefully makes sense. So now I'm on a different machine and I cloned this repository. Now I mentioned before that a link to the remote repository would be set up, and indeed if you run just git remote, you see a list of all connected remote repositories, and there you see that an origin remote repository exists out of the box. With git remote get-url, you also see the URL of that repository, and you see of course that this is that repository URL of that repository here. So this was all set up automatically. It is worth noting though that in this URL, the username of the user of that repository is missing, which also should make sense because keep in mind, we're simulating that we're on a different machine here. Possibly we're even an entirely different person, and therefore of course we don't have access to that username or to that GitHub account of the original repository creator. And indeed, going forward, I am going to assume that I'm a different person on a different machine because I want to show you how multiple different accounts can work together on the same repository. So now we cloned it, we have it on our local machine. Now let's say we want to make a change to that code. So we want to make changes to that website code, and keep in mind we're a different person on a different machine. Now if we want to make such a change, then we might want to create a new branch for the same reasons as before. So I'll create a new branch, which I'll name feed. And now let's say what I want to do is for this website here, I want to change some styling in styles CSS. And in there, I maybe want to change the color of this title text here. Therefore, I'll name this branch feed-color. Name is of course up to you. Now here I can simply pick a different color, let's say a more orange color, doesn't matter, with this hex code here. And then I save this file, and as before, I then stage this styles CSS file or all files, which in this case is only that styles CSS file since that's the only file that changed. And I create my commit, where I say changed title color. So that's all something we learned before. Now, of course, I want to make sure that this change is available in this remote repository. And we learned before that what we can do is we can run git push origin feed color to push this new branch to this remote repository. The link is already set up, so this should work, right? Well, no. If we try this, we get a permission error. The permission is denied, to be precise, and the reason for that is that I'm on a user here that does not have permission to edit this code. So what can we do now? So how can we now get our local changes to this Git repository, which we did not create and which we don't own here on GitHub? How can we push these changes to this repository? As you saw before, we don't have the permissions for that. Well, there are two main ways here. We could fork it, and I'll get back to forking later, but if we did not fork this repository and we instead cloned the original repository as we did it, then we simply have to reach out to the creator of that repository and basically ask for permission to push to this repository. Now, of course, we could reach out with help of contact details that might be mentioned here in the README, but one way we could reach out is to create an issue. Now, very important, I don't want to say that you should use this issues feature to contact people on GitHub. Instead, this issues feature is a feature meant to be used to report bugs or possibly suggestions. Nonetheless, here, our suggestion could be to use this color, and therefore we could share our suggestion here, and then either the original creator of this project implements this suggestion. In that case, it would be fine that we can't push our code because our change then still made it into the project. Or the suggestion is not picked up, then we have to live with that. But there also is a third option, and the creator of the project might ask us to basically, make that change ourselves because they like that change, but they don't have time to implement it themselves. And that might be what we're hoping for here. So therefore, we can report a new bug, or in our case, make a suggestion by clicking on New Issue here. And keep in mind, I am in this second account who does not own this repository. And then here we might give this issue a title of suggestion, change title color, and then we write some text where we go into more detail, where we could say, I think it looks better if the main title is a bit more orange. The styling rule could be changed like this. And here we're again using Markdown, and we can add some code by adding 3 backticks here and 3 backticks here and writing CSS after these 3 backticks to basically tell Markdown that we have a CSS code snippet between these wrapper backticks here. And then we simply grab our updated code here, this H1 code, and paste this in here. That could be our description text. Of course, it depends on which kind of bug or issue you're reporting or which kind of suggestion you have, what you want to write here. You can also see a preview of what will be posted, and you can look up this Markdown help I showed you earlier. So here I'm now submitting this new issue, and now this was reported, and hence we have this 1 here. Now this repository has 1 issue, and that's our suggestion. Now here I'm back on GitHub with that main user who did create this remote repository and who owns this remote repository, as you can tell by the fact that I do have this settings button here. And here I'm now seeing that a new issue was reported, or in this case a suggestion. I can read it and maybe I decide that this is a good idea and should be implemented. But I don't have time to do it myself now, and for some reason I trust this person. And of course that's maybe a bit unrealistic. You typically don't start trusting strangers just because they reported one suggestion, but for the sake of this demo, let's say we want to allow this person to edit the code of this repository. Again, not necessarily something you want to do all the time, but here I want to show you how people can work together on GitHub. Therefore, what we want to do is add this person as a collaborator to this repository, because right now this other person can't push to the repository as you saw, and now I want to make sure that this person is able to push. For that, as the owner of the repository, we can go to Settings and then to Collaborators. And here we can add other GitHub accounts who should have write access to this repository, so who can push to this repository. Now, GitHub also has some other features in their paid plans. There you can have organizations and teams with team members. And of course, there you can also manage access permissions for repositories. But for public repositories with such a free plan, we can add collaborators. So here I can now start adding people who are able to collaborate. And as you see here, I need the username, which in this case is maxacadamine2 for my second user here. So I invite this person to collaborate here. Now that other person should receive an email which invites it to collaborate. And if that other user clicks that link in that email, they can accept this invitation. And with that, as you can also see up here, we now have push access to this repository. Now, as the main owner of this repository, so here maxacadamine1, I still might want to make sure that this other person can't push to the main branch. So here under Settings Branches, we can actually set up a branch protection rule and select our main branch here and require a pull request for this main branch, which means that for the main branch, you're not able to just directly push into it. Instead, you have to open a so-called pull request, which is something I'll get back to later. Here, I'll now create this branch protection rule, and now people should not be able to directly push into the main branch. To other branches, it's possible, but not the main branch. Now here in this example, that's just fine because I did create a separate branch, and now that I have been added as a collaborator, I want to push this branch to this GitHub repository. In order to do that, I just have to do one thing, and again, keep in mind, now here I'm on that second account. I have to change that URL of my origin, so of my remote repository, that link URL, and I have to include my GitHub username in order to make sure that I'll be prompted for a password, which then allows me to successfully push to that repository, because I still must authenticate my request. So therefore, I'll grab that URL again, add it here, but in front of github.com, I'll add my username, which in this case is maxacadamine2. Because I'm on that second user. Hit enter, and now if I want to push this feed color branch, I'm again asked for a password. So therefore now, as this second user again, as you can see here, I have to go to Settings and use such a personal access token. Because this is on a different machine, different user, I need a new token. So generate that token with any name of your choice, give it repo permissions, generate it, copy the token. Again, you'll only see it once, as it also says here, and use that for pushing. And now that branch was pushed successfully because there was no branch protection for this feature branch. Therefore, here we see that this branch was pushed, and as the owner of this repository, we also see that this branch is there now. And that's now the part where we might want to merge it into the main branch. And it's not a good idea to directly push to the main branch. That's typically not what you want to do, because you want to give the owner or your colleagues a chance of reviewing your change instead of directly pushing it into this main branch, which is typically the production branch, the branch that is responsible for the website that's currently live, and a branch that might trigger an automatic deployment flow once pushed into it. That's why we also set up this branch protection. So in order to get our changes into the main branch, we'll now create such a pull request. So we made these changes as this second user, we pushed this branch, and now we want to make sure that these changes are actually merged into the main branch. Now before, we always merged locally, and then we had the updated main branch. But now that's not an option because we won't be able to push that updated main branch. Indeed, I can show this if here on my second user's machine, I check out the main branch and I merge this color branch. That of course works. But if I now push this main branch to origin, you will actually see that this is blocked because I have this branch protection turned on. So that's not an option. Instead, what we want to do, and what is extremely common and actually the typical way of merging branches into the main branch in bigger projects that use GitHub, is to create a so-called pull request. A pull request is a request that requests others, for example, the owners of this project or our colleagues, maybe our boss, to pull our changes into a given branch, typically the main branch. And of course, as part of that process, our boss, our colleagues, or whoever has the right to accept these pull requests has a chance of reviewing our code. That's why in all big projects, and especially in all open source projects, if you're contributing to the project and you want your changes to be included in the main branch, in the production code, you open such a pull request. And that's what we're going to do here. I'm on the GitHub account of that second user who's not the owner of this repository, as you can tell by the missing settings tab. And here I pushed my feed color branch. Now I got a button for creating a pull request here, but we can also do this from inside the pull requests tab here. Here we can create a new pull request. And what we do here is we select the branch into which we want to merge. So that's the main branch. And then the branch that should be merged. That's the feed color branch. I select this here and I then get a preview of what will be changed. In this case, it's in the styles CSS file where the color will be updated. So in the end, what will happen is a merge, the same thing we did locally, but it will happen on GitHub after giving our colleague or the owner of the project a chance of reviewing our upcoming changes. And of course, if you're collaborating, having processes like this is important in order to make sure that code isn't broken or unintended changes are introduced. So here we're creating this pull request here, and therefore I'll click Create Pull Request. And now we can give this pull request a title, like Changed Title Color, and a description. I changed the title color as suggested in, and now we can even link the issue that we created to give this pull request some context. To do that, we just have to get the number of that issue, which you can see here. In this case, it's number 1 because it's the first issue. And then here we can type #1, and GitHub will automatically suggest such a link. If we preview this, we see that a link was indeed added automatically. That's a nice feature of GitHub because GitHub is all about managing code and collaborating on code. That's why it has many nice features like this one, where we can easily link an issue in a pull request. Indeed, we can also easily link issues or pull requests in other issues. So you can link all these things together. That's really quite nice. So with that, we have a nice description. And now I'll create that pull request. Again, I'm still on that second user, that second GitHub user. Now what we see here is that a review is required because we turned on that branch protection where we actually set that at least one reviewer is required. So therefore here we can't merge this pull request because we did not create this repository. But we created it, and now we can wait for the owner of this repository to merge this. So here I am on this main account, who is the owner of this repository, and there if I reload the page, I see this pull request. Now I can take a look at it, and here I see what's going on, I see the description, I can take a look at the commits that will be merged and which files will be changed, and I also see that a reviewer is missing. Now, since I'm the owner, I could still bypass this, but I can also request myself as a reviewer here. The person who opened this pull request could have done this as well, but I can edit this pull request if I'm not fully happy with it, as I'm doing here by adding me as a reviewer. So now that I did add myself as a reviewer, I can add my review. Again, these are all nice features built into GitHub. And that allows me to go through these code changes. And I could add annotations here, which then again can be picked up by the person who created the pull request to make some changes to it. However, here I'm quite happy with that. Therefore, I'll click Review Changes and Submit Review, and I'll actually just approve these changes here. I have nothing to add. I'm just fine with that. Now I left my review, and now I can merge this because now it was reviewed. I'll just do one more thing. I'll add an extra comment where I say closes this issue, so that I say that this issue will be closed by merging this pull request. Hence, I'll comment here and add this comment to the pull request and then merge that pull request. Confirm the merge. And now it was merged. And under issues, I can target this issue here and actually mark it as closed, because this is not an issue or an active suggestion anymore. Instead, this has been implemented. Now, technically what happened is that a merge was performed and added to the main branch, and this is still a new commit therefore in the end, as we did it locally before as well, but now it happened all on GitHub using these GitHub features. This, of course, also means that now there is some code on GitHub that's not necessarily on our local machines yet. Here in that project of that second user, if I run git pull, it therefore now downloads these changes, and actually nothing changed because I merged that feature branch into the main branch there before as well, but technically something did change because I did now really download that merge commit that was created remotely. And of course, if I switch to the project of the original creator of this project here, then I can also run git pull there to download these latest changes and get this updated color. And that's how you can collaborate with others on GitHub, by adding them as collaborators and by then using this pull requests feature here, which we used to suggest a change, review a change, and then ultimately, if everything's all right, merge that change. And that's how people can contribute on open source software, but also internally in teams on private software or on whatever you're working. Okay, so we saw how pull requests work and how we can collaborate if we add people as collaborators. However, I did mention before that you typically don't want to trust everyone who's reaching out to you. You might not want to add everyone as a collaborator, because even though you can protect some branches to make sure that even collaborators can't change everything, you still might not want to give everyone push permission. And therefore here, as the owner of this repository, I'll remove that second account here. I'll remove that account as a collaborator. Therefore, now that other account no longer has permission to push. As we can see, if I'm again back on that second account's machine and I make some change, I break the code here, and then I check out that color branch again and add that broken code and create a commit where I say broke code. If I try to push this branch to remote, which I did before as well, now we're all of a sudden getting a permission error again because I was removed as a collaborator. Now, let's say I'm a totally new person. Technically, it's still that second GitHub account here, but let's say I never was a collaborator of this project. Or maybe I was, but I am no longer, as it is the case now. Maybe I still want to contribute, and not by breaking code, but by doing something useful. Now, let's say I have no chance of becoming a collaborator because people don't just add random people as collaborators. And indeed, that is quite common for open source software. If you want to collaborate there and maybe solve bugs in the code, you won't simply be added as a collaborator by the owners of these projects. And of course, rightfully so. They won't know who has good intentions and who has not. What you can do in such a case to still help is you can fork a repository. Now, if you fork a repository, what you're doing is you're cloning that repository on GitHub so that you get your own repository on GitHub, which is based on this repository. And then since that cloned repository on GitHub will be your own repository, you can clone that to your local machine, make changes, push it to your cloned and owned GitHub repository, and then you can actually create pull requests across repositories on GitHub. That's what we'll do next. So therefore here, as that second user on that repository on which we want to work, I'll click fork. And now this will create this repository for this account, for this second account. So I'll click create fork here, and this will now create a brand new repository on GitHub, which is forked from that original repository. But this is a different repository for a different user. Now we can clone this as we did it before. So here, therefore, I'll again use git clone and name this git demo 2. If I now hit enter, this is downloaded, and I can open this in VS Code. Again, that's now that second user, but it's a new project based on this forked GitHub repository. Now here, I want to make sure that I set my URL correctly for origin. And I'll use that URL of that forked repository here, this URL with .git at the end here. But I'll again add my username here, maxacademind2 at github.com, so that future pushes will take this username into account. Okay, so now here I maybe want to make a change. Not a breaking change, but a useful change. I want to change the color of these links and make it more reddish, something like this. So now I made this change, and I'll actually make that in a new branch. And you can even check out and switch to a new branch after making this change, as long as you haven't committed it. So here I'll name it feed link color, this new branch. And then I'll stage this style CSS file and create this commit where I say changed link color, like this. Now I can push this feed link color branch by using git push origin, which points at my forked repository, which this user does own on GitHub, and push this feed link color branch to it. Now this will succeed using that personal access token from before, and since I added the username to the URL, and now this is on this forked repository. Important, it's not on the original repository. There, if we take a look at that, this branch does not exist. Feed color is that other branch from before. The new branch is named feed link color, and that only exists on that forked repository. Now I want to suggest to implement this change to that main repository. For that, I could again create an issue and say that I want this feature, but I can also create a pull request right away. For this, as this second user here, I'll go to the original repository, and there I'll open a new pull request, just as I did it before. Now, however, I want to compare across forks, and I can click this button here to do that. That now allows me to choose the repository and branch into which I want to merge, and that is that main repository of the first GitHub user, and there the main branch. But I'm selecting my own forked repository as the source, and there the feed link color branch. And with that, I'm now suggesting that these changes of my forked repository, which I own, are merged into that other repository in the main branch, which I don't own. Now, otherwise, it's the same as before. You can see the change here. I can then create my pull request, give this a nice title, changed link color since it looks nicer, whatever, and I can create this pull request here. Now, this requires a reviewer just as before, but I can leave the pull request like this if I want to. So now with that pull request was opened, and back on that main repository with the first GitHub user who owns this repository, I can see this pull request here. Now, I can again add myself as a reviewer since a review is needed. And after adding myself as a reviewer and reloading this page, I can add my review here. I can again take a look at the code and possibly add comments, which then could be picked up by the person who did open this pull request. But here I'm fine with everything, so I'll again approve this and submit my review. And now that this has been reviewed, I could add another comment, but I'll just merge this pull request and confirm this merge. And now with that, we have another merge on this main repository, which is now based on a change that was made in a different repository that was forked from this repository though. And that's the important part. And that's another way of collaborating and contributing, which is also a very common way, especially for open source projects. So you have both approaches, adding collaborators or relying on forks, and it simply depends on which kind of project you are working on. If it's open source or if you're working on it in a small team, possibly in a private repository. GitHub has all these features and many features more, but these are especially important features since GitHub in the end is all about storing code remotely, but also about collaborating on that code, working together on that code. And pull requests, collaborators, forks, these are all features you should know when working with GitHub. And that's it for the GitHub part and for this section in general. You now did learn a lot about Git and its key commands, how to create commits and what commits are, how to work with branches, and you learned how to work with GitHub, how to push code to it and use it to store your code remotely, how to get that code and how to get updated code, and how to collaborate. These are the essentials you must know about Git and GitHub, and if you do know them, as you do now, you're well prepared to dive deeper into Git and GitHub and use it in your everyday work.